So what is the Coulomb's law? Coulomb's law is all about the interaction force acting between the 2-point charges. Now if you will take the 2-point charges plus q1 and plus q2, then they will start to repel each other. Why? Because they having the same polarity. So if I am keeping the two charges plus q1 and plus q2 at a distance of r, they will apply the force. That force you can write F12 vector on charge 1. That means force acting on charge 1 due to charge 2 is F12 vector. In the same way you can write force acting on charge 2 due to charge 1 is F21 vector. In the same way, if you will keep two charges having opposite polarity, magnitude I will take same that I have taken in this case, it is a plus q1, but now I change the polarity of charge q2, that is minus q2. Then the forces that will act between plus q1 and minus q2 will be same in magnitude wise, but the nature of the force will be attractive now. So it will be F12 vector and F21 vector, and both will start to attract each other now. So now Coulomb's found that the magnitude of these two charges, that means F12 vector equals to F21 vector. It means the force by which charge q1 is repelling charge q2, with the same force charge q2 will repel q1, or vice versa. You can say that the force by which charge q1 is attracting charge q2, with the same force charge q2 will attract charge q1, and the magnitude of these forces is proportional to the product of the charges. That means F is proportional to q1 into q2, and it is inversely proportional to square of their distance. So F is inversely proportional to r square. If I want to write this equation form, then I can write F is proportional to q1 q2 by r square. And if I will remove this proportionality, then I can write this equation as F equals to k q1 q2 by r square. You will find this equation is similar to the gravitational force acting between the 2-point masses. That is what? That is F equals to capital G m1 m2 by r square. But there you are taking the mass of 2-point objects. Here you are taking charge on 2-point object, and there the constant is capital G, and here constant is K, and this K is known to be as a Coulomb's constant. We will discuss about this Coulomb's constant. So if I will take K value, I can write it K equals to 1 by 4 pi E. If two charges, if I will take two charges plus q1 and plus q2 at a distance of r, and if medium between these two charges is a free space, if no medium is there, then K value equals to 1 by 4 pi epsilon naught, and then this value is nearly equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. But if you will keep any medium between these two charges, then the interaction force between these two charges, net interaction force between these two charges will reduced. It means here this E value you can write epsilon naught ER, where this ER is relative permittivity. Here epsilon naught is permittivity in free space. So if we take any medium between these two charges, then the net force acting on any charge will reduced, and there you will not take epsilon, there you will take E, and that E is nothing but the epsilon ER, where ER is what? Relative permittivity. You can understand how it happened. Just try to understand this. For example, if I take two charges, plus Q1 and plus Q2, and there is no medium between these two charges, then at that time the force is acting F12 vector on charge 1 due to charge 2, and on charge 2 the force is F21 vector. No space, that means space is distance between these two is R, but no medium is there. The medium is free space it is. So here the force will be maximum between these two charges, and that value you will write F equals to 1 by 4 pi epsilon Q1 Q2 by R square. But if you will keep certain medium, that means if these two charges is in some medium, then what will happen? Is the force applied on charge Q2 by charge Q1 or on charge Q1 by charge Q2 will decrease or increase? Actually, the force acting on charge Q1 due to charge Q2 is not changing. Is not changing, yes. It will be remain same. F12 vector and here F21 vector. But because of medium, the force get decreased. Fm vector, the net force get decreased. Net force F net vector you can write, this is what? F12 vector minus Fm vector, and that is nothing but the 1 by 4 pi E Q1 Q2 by R square. So if the question is that is force between two charges, that means force applied on any charge due to other charge will decrease or increase due to change in medium, then the answer should be that force due to charge, the interaction between charges, not changes. Actually net force changes on any charge because of the medium, but whatever the force acting on charge 1 due to charge 2, it is same, it is not changing due to any medium. If you will take any medium, its force will remain same, it is not changing. So I think so you understood what is the Coulomb's law.